You will learn how to remove background noise using Adobe Audition. I will use these two audio samples for the demo. One audio file has quite a strong fan noise. The other one is not as extreme as the first one but still has some noticeable noise. If you know how to reduce noise from these two audio samples, you can remove any kind of white background noise using Adobe Audition. I will drag the sample with stronger background noise to the Audition editor area. Let's hear the audio sample to get an idea of the original recording and the noise.
During this recording, the ceiling fan is on, so it is expected a very strong hissing noise will be recorded. I think Audition offers a bit more flexibility in audio in noise removal than Audacity.
I recorded this audio keeping this ceiling fan on. It was spinning like this while I was recording. For this reason, such a strong wind noise was captured by the microphone. The overall volume level is also a bit lower than it should be. If I want to upload this voice to YouTube, it should be normalized to -3 dB. Adobe Audition has a shortcut to normalize to -3 dB. I made a mistake by applying normalization when a small part was selected. I will undo and deselect that part. If nothing is selected, Audition applies the effect on the whole track. This time, the normalization is applied to the whole track. As you can see, the overall waveform grew vertically. The noise became louder as I normalized to a higher volume. This noise also becomes louder in the spoken parts of the audio.
During this recording, the ceiling fan is on, so it is expected a very strong.
You may ask if this normalization was necessary as it increased the noise more. At some point, I had to make this audio louder through normalization. So it would bring up the noise at that point then. If I reduce noise after taking the volume to the proper level, I would know how much noise would be in the final audio. You can find noise reduction effects in Noise Reduction Restoration. I will apply a noise reduction process as it will work best for the kind of noise I have. The noise reduction process works best for hissing or consistent white background noise. To use noise reduction process, you have to capture a noise print first. I can select a noise-only part and capture noise print. I can also do that after going into the noise reduction process. I will go to the noise reduction process and then capture noise print. I will return to the default presets so that your Audition settings match mine. You can see a warning at the top asking to capture noise print. Noise print is the noise sample we give to Audition. Audition then removes noise similar to that noise profile. Before doing that, I will set a few options for this display area. I will enable the preview editor. We will be able to see what changes are made in the audio for the original recording. Ensure the mirrored is selected so the preview starts with what we have in the track now. I will enable spectral frequency display. Adobe Audition made the audio visualization process easier with this spectral display. It helps make audio editing easier. In spectral display, you can see which frequency has how much energy. Brighter colors mean the energy or volume of those frequencies is higher. I will get back to the noise reduction process. As I said, we must capture a noise print from the current audio. This noise print should contain only the noise we want to remove and has a consistent pattern. It is good practice to record some noise without talking at the beginning of the recording. However, it is not necessary to take the noise print from the beginning. It can be anywhere from the audio as long as that is the noise we want to remove. A half second's noise is enough, though I have a noise longer than that. While doing noise reduction in Audition, you should use a headphone. Because the sample I have selected has a very tiny bit of anomaly, it also has a mouth noise. If I zoom into this spectral display, you may see an extra vertical line here. It is very thin, but it is there. If you are using good headphones in a quiet environment, you can also hear that. Why am I focusing on the mouth click so much? It has a very important reason. Your noise selection should contain only consistent background noise. That mouth click can destroy the noise pattern, and Audition will remove audio from here and there for such an inconsistent pattern. So I will select a consistent noise-only part with no such anomaly. Remember this point, and while selecting noise print, ensure no other type of inconsistent noise is there. Otherwise, Adobe Audition's noise reduction process will not work that well. This noise selection is consistent as we hear and see in the spectral display. Click on Capture Noise Print. Looking closely at the spectral views, you will see more black regions in the preview editor. Silence becomes black in spectral display. The bottom is the preview editor, which shows how the audio will look if I apply these settings. I will move the settings pop-up to the side so that you can see more of the spectral display. So you can see more black regions in the preview window. It shows the spectral display of how it will become after removing the noise. Keep in mind, these are not two different waveforms. The top one is the audio which we can play. The bottom one is the preview which only gives us a visual idea of how things will become after applying the effect. If I play the audio, you will hear how the sound will become after noise reduction. I already activated the loop playback, which is the blue icon here. While reducing noise or applying any other effect, looped playback helps to assess the situation. There is also a toggle button to activate or deactivate the effect during live playback. It is green, meaning the effect is active if I play audio. Let's listen to it a bit.
During this recording, the ceiling fan is on, so it is expected a very...
The noise is reasonably reduced, though there is still some noise remaining. If I play and switch between the on and off effect, you will understand how much noise has been reduced.
During this recording, the ceiling fan is on, so it is expected a very strong...
So you see how much noise gets reduced if the effect is active. Your understanding of noise reduction will be affected by the listening device you are using. If you use headphones in a quiet environment, you will understand better how much noise gets reduced. If you're listening on a laptop speaker or smartphone in a bit noisy environment, you may find it difficult to understand how much noise is getting reduced. The noise reduction I got was with the default settings. Let's see how we can change some of the settings and if we get any improved noise reduction. The graph you see here will give you an idea of how well the noise reduction will perform. The red dots are low volume noise, and the yellow dots are higher volume noise. The green dots are the threshold noise floor. Below the green dots or threshold noise floor, Audition can reduce noise. You can drag the blue line to adjust the green dots. If you take the blue line higher, the green dots will come closer to the yellow dots. Theoretically, if we can take the green dots above the yellow dots, all the noise will be gone. But that has some practical issues that I will discuss shortly. The graph can be seen in a linear fashion or logarithmic fashion. With the logarithmic view, the frequency distribution over x-axis is changed. You have to be quite an advanced user to use that thing, so I am not getting into details. Let's listen to how it sounds with this adjusted threshold.
During this recording, the ceiling fan is on, so it is expected a very strong hissing noise will be recorded. I think
the noise gets reduced more than before, but the sound quality is also degraded. It sounds a bit hollow. It is a common issue with noise reduction. With greater noise reduction, the audio itself degrades, thus leading to a poor listening experience. So we have to find a balance where we can reduce noise without degrading the audio quality much. Moving the blue line too much higher results in a poor audio experience. You should move it a little or just around some frequencies. I will reset the graph from the default preset and have to capture noise print again. I will listen to the selected noise to make sure only desired noise is selected. I will adjust 3 settings from here while listening to the audio. The noise reduction slider sets the strength of the noise reduction algorithm. If you mouse over the sliders, you will see a tooltip of what it does. Noise reduction strength means how aggressive the audition will be in noise reduction. The more value you set in this slider, the more aggressive it will be in noise reduction. The Reduce by slider sets the noise reduction amount when noise is found. So when Audition detects a noise, it will reduce that noise by this amount. The third setting I will adjust is the spectral decay rate, which I will discuss a bit later. Let's play and listen. I had the noise selected, so it looped there. I will deselect this, and the whole audio will play. While I play audio, I will also check the output noise only, to understand what is getting reduced, and I can adjust the settings.
During this recording, the ceiling fan is on, so it is expected a very strong hissing noise will be recorded. I think Audition offers a bit more flexibility in audio in noise removal than Audacity. During this recording, the ceiling fan is on, so it is expected a very strong hissing noise will be recorded. I think Audition offers a bit more flexibility in audio in noise removal than Audacity. During this recording, the ceiling fan is on, so it is expected a very strong hissing noise will be recorded. I think Audition offers a bit more flexibility in audio in noise removal than Audacity. During this recording, the ceiling fan is on, so it is expected a very strong hissing noise will be recorded. I think Audition offers a bit more flexibility in audio in noise removal than Audacity. During this recording, the ceiling fan is on, so it is expected a very strong hissing noise will be recorded. I think Audition offers a bit more flexibility in audio in noise removal than Audacity. During this recording, the ceiling fan is on, so it is.
Okay, so with more aggressive noise reduction, my voice is also getting reduced when I check output noise only. Most noise reduction occurs while the spectral decay rate is 0%, and no significant noise reduction is done when it is 100%. Setting a value between 40 to 70% for the spectral decay rate is advised. I suggest you start with 0 and increase up to 40 and check how it sounds. Sometimes noise reduction can introduce sudden strange sounds in the audio. Smoothing can help to reduce that kind of sound. If any new sound is introduced after reducing noise, that is called an artifact. For voice recording, a smoothing value of 2 can reduce artifacts. I suggest keeping the rest of the settings to their default. A precision factor greater than 7 will take more time to process the noise reduction, but we will not find any noticeable difference. For standard voice recording, transition with 0 dB works best. It attenuates noise reduction with decibel precision, which is useless to us, because we have no way to measure which noise to reduce at which dB. So use 0 dB with transition width. FFT size 4096 also works okay for us. An increased FFT size does not provide any noticeable difference in noise reduction. You can use an increased FFT size if you wish, but you will not feel any difference. However, you cannot go less than 4096. If you go less than that, you might notice noise reduction is not performing that well. These smaller FFT sizes are for those who don't have a good noise sample. For example, if you have a pretty small noise sample, quite less than half a second, the default 4096 FFT may not work. Only in that cases you need a smaller FFT size. Otherwise, stick with the default. If you want to know the details of any settings, you can click the information icon inside the settings pop-up. It will take you to an Adobe manual page. It provides some detail about how things work with Adobe software. If you want to take your learning deeper, this is an excellent place to start with. Let's get back to Audition. If you find satisfactory settings for noise reduction, apply the effect from the Apply button. Then the change will be permanent. We can see that noise reduction has been applied to the audio from history. History shows what changes we made over the audio and travel back to a previous point if we wish.
During this recording, the ceiling fan is on, so it is expected a very strong hissing noise will be recorded.
I think Audition did a good job of reducing the strong fan noise. It was audio with an extreme kind of white background noise. Ideally, your recording should have way less white noise. I have another piece of audio that has noise that we get practically most of the time. I will open that audio and make a quick noise reduction to show you how it works in these cases.
During this recording, the AC unit is on and the microphone is facing in the direction from where the AC.
You can see less noise than in the previous audio. I will take the output level to the standard -3 dB. I have some bell noise for this audio in the beginning silent part. So I will select a noise sample from the middle where it has constant background noise. Like before, I will go through the noise reduction process. Audition has the noise print from the previous audio, not from this one. The noise graph it is showing is from previous audio. If I capture the noise print from this audio, you will see the noise graph will be lowered as it has less noise. So you see, the noise graph has been lowered in this part. I will now listen to the audio and adjust different settings. I suggest you take a closer look at how I am doing that.
During this recording, the AC unit is on and the microphone is facing in the direction from where the AC wind noise is coming. I think Adobe Audition offers a bit more flexibility than Audacity in noise reduction. During this recording, the AC unit is on and the microphone is facing in the direction from where the AC wind noise is coming. I think Adobe Audition offers a bit more flexibility than Audacity in noise reduction. During this recording, the AC unit is on and the microphone is facing in the direction from where the AC wind noise is coming. I think Adobe Audition offers a bit more flexibility than Audacity in noise reduction. During this recording, the AC unit is on and the microphone is facing in the direction from where the AC wind noise is coming. I think Adobe Audition offers a bit more flexibility than Audacity in noise reduction. During this recording, the AC unit is on and the microphone is facing in the direction from where the AC wind noise is coming.
I set the noise reduction to 75% and reduce by to 31. I set the spectral decay rate to 40%. I found that my audio quality is okay with the most noise reduction in these settings. When I had higher values for those, my audio quality degraded. I hope you now understand the process of noise reduction. It is about finding the best combination where noise gets reduced, but not the audio quality. After reducing the noise, both of my audio samples have some visible noise in the meter. Even though I see some noise in the meter, it may not be that much audible. If you are editing audio for YouTube or other social media platforms, some noise in this meter will not hurt. Because it is not audible or distracting, your goal would be to reduce some noise to give viewers a smooth experience. If you are recording something like audiobook where any noise in the meter is not accepted, you have to think of a different strategy. You have to record your audio in a quiet and controlled environment so that your recording gets as much low noise as possible. Then you can take out those little amounts of noise using the noise reduction from Adobe Audition. I discussed in detail so that you understand how things work in noise reduction. If you have any questions, let me know in the comment. Thanks for watching, and see you next.